Hello, my name is Adam Mayhood. I am a postdoc at CU Boulder, University of Colorado Boulder, and I'm just going to give a quick little overview of this software package that we made called firedpy. So that's fired stands for fire event delineation, and then py is Python. So this is a package that downloads the raw Modus burned area product from the internet for whatever area of interest you want, and then just like processes all the data for you and then outputs fire perimeter data set. And we've been creating it for every country in the world, and we're almost done. So just for example, here is Angola processing. It's taking a really long time because it's a huge country and it's one of the most fire prone areas in the world. So it's just cranking out 57 gigabytes of RAM for like days and days to process. But so yeah, luckily here in America, we don't have that much fire to deal with. Anyways, so I just want to give a quick demonstration of what it is and how you use it. So first of all, we have our GitHub page that has the software. So you just clone this GitHub package, and then the easiest thing to do is just download one of these data sets. So here we have all these links to all these different countries. Let's see if we want to go get some fire data for Togo. We just click on this link. Then we got this CU Scholar, which is our kind of in-house data repository. Click the download button, and you can just get the fire perimeters for 2001 to 2020. So we have almost every country on here. And then we have installation instructions if you just want to make your own fire perimeter data set. So if you have a specific area of interest or whatnot, or if you want the most recent fire data and we haven't caught up to the keeping it updated yet, we got these installation instructions. The easiest way to do it is to run it from a Docker container. So we've created a Docker container that has the whole software environment that you need. And so you just need a computer with sufficient RAM to run firedpy. So here's some quick instructions. And now I'm just going to go over to a console here that I have running on a AWS cloud to give a quick demonstration. So now this thing's kind of all set up. So we just need to kind of activate firedpy here. And then, so now we'll just say firedpy. And then I got a little cheater text file here. And then all these other things should be, all the other options are just set to the default. So, but what this is the firedpy command. And then -AOI stands for area of interest. And then within the firedpy folder, or within the firedpy repository, we have a ref folder, which stands for reference. And then we have just like all these, just like every country in the world, we have a shapefile for that has been transformed to the Modus sinusoidal projection. So that way you don't have to go through that hassle of reprojecting stuff if you have it. So I've referred to the reference folder, and I've gotten Samoa because I know ahead of time that Samoa has had like one fire for the past however many years of this Modus burned area product. So right now you'll notice that firedpy has figured out what Modus tile it has to download, and now it's just going and downloading all these 249 HDF files for you. Yeah, and that's going to take a little while, but it shouldn't take too long. What else can we talk about here? Okay, so I'll just go through these the parameters. So the first thing you can do with firedpy is you can control the spatial and temporal parameters that firedpy uses to aggregate burn date pixels into fire perimeters. So the Modus burned area product is just a raster with every pixel is a, a day of the year. And so what firedpy does is take those 249 monthly rasters and stacks them into a cube, a spatial temporal data cube, and then it runs this algorithm on this three-dimensional net CDF that it creates using the spatial and temporal parameters. And then it outputs fire parameters. And it's kind of hard to say what are the correct spatial and temporal parameters. It's not that hard in the United States because we have like MTBS and all the other data sets to validate off of, but other countries have different patterns of fire and no fire data. So if you're in somewhere where I've never been and you know more about the fire there than me, you can tailor these spatial and temporal parameters to work correctly for your country of interest. Next, we have the area of interest is the main argument, where I was just using, referring to a file in the reference folder, but you can also just say like a modus tile and it'll just download those tiles and do the analysis. And then we have some ancillary data that you can do. You can say, you can have it include ecoregions. So it'll just extract the ecoregion that each fire event is in. And you can either use North America ecoregions or world ecoregions, the WWF ones, that you can output either as a geo package or a Esri shapefile. Although I think that is kind of not working correctly to do the Esri shapefile right now, but that'll be fixed soon. And then you can kind of change the base file name of it, and you can create daily polygons as well. So you can output, instead of just one event, you can have one individual polygons for each day of the fire event. So you can kind of see the day-to-day progression of the fire. And you can also restrict the temporal extent. So by default, it just starts at the very beginning of the modus record. It ends at the last date of that they have the data process to, but you can have a smaller temporal window if you're trying to get like a specific year or something like that. So let's check our downloading process. Oh, and it's already done. So like I said, there's like one fire event in this whole thing. So I'll just go back here. So it downloaded these HDF files. It built the net CDF out of the HDF files, and then it ran the algorithm on here. Blah, 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 did all this stuff, saved the table, yada, yada, yada. And now I'm going to do a little quick thing to just show you what we got here. Now I'm going to go to my S3 bucket, which I forgot to prepare. Oops. And so you'll see here, also it automatically creates a README file that kind of gives you the summary of everything that's in there. And then we're going to download this. We're into QGIS here. Fired Samoa. Boom, there it is. So just open this attribute table here. We have an ignition date, an ignition day of year, ignition month, last date, yada, 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 the whole area, the fire spread rate, the maximum growth, the day of maximum growth, how much area that burned in that day and everything, the ignition coordinates, total perimeter. So some good information. And then as another example here, we can show you a bigger file. So here's the Republic of the Congo. And so that's a lot of fires. Yeah, let's see, that's about it. So that's firedpy. It just downloads and processes a bunch of data for you that you don't have to do. So you don't have to go through the whole process yourself. And we already did it for almost every country in the world, and we're in the process of finishing it all. So yeah, hopefully people can find this useful.